So whenever we talk about particles here, we're referring to Avogadro's constant, which if you remember, and we always get given this information, we don't have to remember it, but 1 mole of any substance contains 6.02 times 10 to the power 23 particles, and that value is Avogadro's constant. So to do this, we've got our triangle. Particles is moles times AC. And a little bit of thinking on this one. We've got magnesium chloride, so MgCl2, and I'm trying to find out how many lots of chloride ions are in there. So you can see here that there are going to be 2 lots or 2 moles of chloride ions inside magnesium chloride. So therefore, if I want to know how many actual ions there are going to be, I'm going to have to work out if 2 moles times by Avogadro's constant. Okay, so to do that, we'll rearrange this equation. So I've got the particles, is what I'm trying to find, is moles times AC. So let's just write that over here. We always have to write down the equation we're going to use. So the number of particles is moles times by Avogadro's constant. The number of moles we've just shown is 2 lots of chloride ions, and then we've got Avogadro's constant 6.02 times 10 to the power 23. When you work that out on your calculator, that is going to give you 1.2 times 10 to the power 24, and this time they will be ions. This next one here is the same type of question, but we're looking at how many particles are there in. For instance, this is sodium ions this time in 1 mole of sodium carbonate. So again, what we can see here is that if I have 1 mole of sodium carbonate, Na2CO3, then I've got in there 2 moles of Na plus ions, because in front of, in here we've got 2 lots of sodium, so 2 lots of sodium ions. So again, my equation to find the particles is going to be moles times by Avogadro's constant, and again we've got 2 lots of moles times by Avogadro's constant. Work all that out and we will get the same answer.